Welcome to this explainer. I am absolutely thrilled you're joining me today because we are tackling something fundamental, fascinating, and absolutely crucial for your success. We are looking at the Cambridge IGCSE Mathematics 0580 syllabus, specifically focusing on the core and extended topics of number. But listen, we aren't just going to look at a dry, boring list of requirements. Oh no, we are treating this like a masterclass in exam strategy. We're going to bridge the ancient origins of mathematics with the modern IGCSE number syllabus to show you exactly how to slice through these exam questions with absolute precision. Think of it as ancient warrior wisdom meeting modern exam strategy. Every year, we see students like Alex, who overloads his brain with raw mathematical facts but completely ignores the strategy, or Sam, who rushes through the paper and completely misses what the question is actually asking. By understanding where these mathematical tools came from, you're going to gain that deep intuitive grasp needed to outsmart the exam. From the earliest astronomical calculations to the complex exponential growth models of today, this is your complete strategic blueprint to the language of numbers. Let's get into it.
You see, mathematics wasn't just invented overnight. It wasn't some sudden flash of insight in a modern laboratory. It was meticulously built across millennia by brilliant thinkers. Ancient Hindu mathematicians who laid the structural groundwork for literally everything we study in the Cambridge syllabus today. Way back in 1300 BCE, a teacher named Lakata was already applying geometry and trigonometry to astronomical calculations. Think about that for a second. Thousands of years before modern telescopes, math was unlocking the stars. Then, around 500 CE, Aryabhata took things even further. He worked on approximations for pi, a concept you are going to use constantly in your 0580 exams, and he mapped out the trigonometry of the sphere, realizing that planetary paths were elliptical, not just perfect circles. In the 7th century, we see Brahmagupta, who we'll talk about in just a moment. And then, skipping to the 12th century, Bhaskara, one of the greatest mathematicians of all time, discovers critical formulas like the sine of a plus b. This brilliant work formed the bedrock of global mathematics. These were the original master strategists.
Now, what's really interesting is the specific historical breakthrough regarding the 7th century mathematician Brahmagupta. He was the very first to treat zero as a number in its own right. It sounds so simple to us today, doesn't it? Zero, nothing. But treating zero not just as an empty placeholder, but as an actual manipulable mathematical value was a total paradigm shift. It was a real game changer. This singular breakthrough paved the way for the development of the decimal system. Without zero, the decimal system completely collapses. And without the decimal system, the entire modern mathematical syllabus we're about to decode simply wouldn't exist. It is the absolute foundation of your IGCSE number module. To make this vast syllabus manageable, we've organized it into 5 structured themes. We've just covered the ancient origins. Next, we'll hit defining numbers and sets, then the mechanics of calculation, accuracy and estimation, and finally, real-world applications.
Section 2. Let's start with the absolute foundations, classifying and grouping the exact numbers we use to quantify the universe. This beautifully illustrates our starting point. Looking at this incredible close-up of a pine cone, we're reminded that numbers aren't just human inventions. They are woven right into the fabric of nature. Objective E1.1 requires you to identify and confidently use a whole spectrum of number types. Now, a student like Alex might just try to memorize a list, but you need to truly understand them to spot the tricks in the paper. You need to know your basic natural numbers, the counting numbers. You must identify integers, which include positive numbers, negative numbers, and our powerful friend, zero. You'll need to work with prime numbers, square and cube numbers, common factors, and common multiples. But it doesn't stop there. You absolutely must distinguish between rational numbers, those that can be written as simple fractions, and irrational numbers like pi or the square root of 2, which go on forever without repeating. Knowing this vocabulary is like knowing the rules of engagement before you step into the exam hall.
Moving to Objective E1.2, we shift from individual numbers to groups of numbers known as sets. A set is simply a collection of objects described with very specific mathematical notation. You've got to be able to use language, notation, and Venn diagrams to describe these sets and clearly represent the relationships between them. For example, set A might be defined as x such that x is a natural number, or set C defines a range, where x is greater than or equal to A and less than or equal to B. Understanding this precise notation is totally non-negotiable if you want to clearly communicate your logic to the Cambridge examiners.
Before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, moving into Section 3, the mechanics of calculation. This is where we roll up our sleeves.
These objectives dictate the core mechanical operations you're going to perform day in and day out. Under E1.3, you need to confidently calculate with squares, square roots, cubes, and cube roots. E1.4 asks you to use directed numbers, numbers with positive or negative signs, in practical situations. Then we hit E1.7, which is absolutely critical: indices. You must understand the meaning of fractional, negative, and zero indices, and flawlessly use those rules to simplify expressions. This is where a lot of students trip up. E1.8 is all about the 4 rules for calculations applied across whole numbers, decimals, and fractions. This means strictly adhering to the proper use of brackets and the order of operations. Do not be like Sam and rush this part. Missing a bracket changes everything. Finally, E1.13 reminds us of a vital survival skill. You must use your calculator efficiently and apply appropriate checks to verify your accuracy. Remember, a calculator is only as smart as the strategist typing the numbers into it.
Beyond simply calculating the right answer, you must perfectly format your results so the examiner knows you are in complete control. Step 1 relates to objective E1.7, standard form. You must write massive or microscopic numbers as a multiplied by 10 to the power of n, where a is greater than or equal to 1, but strictly less than 10. Step 2 requires you to convert fluently between decimals, simple vulgar fractions, and percentages. You have to recognize their equivalents instantly. And Step 3 covers ordering these quantities by magnitude. You must demonstrate complete mastery of the mathematical symbols for equals, not equals, greater than, less than, greater than or equal to, and less than or equal to. This is how you present a flawless argument on paper.
Section 4. Precision is vital, but so is understanding the strict boundaries of that precision. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's contrast 2 different approaches to precision. First, we have estimation, covered by E1.9. Here you must make sensible estimates and give approximations to specified significant figures and decimal places. Critically, you have to round off your final answers appropriately for the context. Then, on the right, we have upper and lower bounds, governed by E1.10. This requires you to identify the exact, strict boundaries for data that has been rounded. If you're on the extended syllabus, you have to take this further and obtain upper and lower bounds for the solutions of problems when the starting data is rounded. This is the difference between an amateur guess and master-level exactness.
Finally, Section 5. We transition from pure abstract calculation into tangible, real-world problems.
Let's map out this highly practical side of the paper. Think of this as a mental data scan challenge. In measurement, E1.14 dictates that you must manipulate 12 and 24-hour clocks, read complex timetables, and calculate average speed. Moving to finance, E1.15 and E1.16 test your ability to convert currencies, extract data from charts, and solve problems involving simple and compound interest. Under proportions, E1.11 and E1.12 test your understanding of ratios, percentage of a quantity, and calculating percentage increases and decreases. These aren't just exam questions. These are the mechanical life skills that dictate the real world.
Now, if you are tackling the extended mathematics syllabus, you have to push these proportion and finance concepts even further. Under E1.12 for extended students, you need to execute reverse percentages, meaning you are given the final amount and the percentage change, and you have to strategically calculate backwards to find the original quantity. Furthermore, Objective E1.17 introduces the incredibly powerful concepts of exponential growth and decay, specifically looking at population modeling and advanced financial curves. Which brings us right back to our beautiful pine cone. Whether you're measuring the expanding spirals of a natural organism or tracking the compound exponential growth of a financial portfolio over decades, these advanced models reveal how deeply math is woven into reality. Nature and numbers are completely inextricably linked. When you see this on the paper, you aren't just solving a problem, you are decoding the universe.
So as you face down everything in this syllabus, from compound interest to complex bounds, remember the ancient master strategists like Aryabhata and Brahmagupta. They started with the stars and the invention of zero, and you are using those exact same foundations to ace this paper. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.